Hi. So it's been a long time, and I'm in between some medical procedure. Something's wrong with my EO, so that is why I took a little break for 2 days, and I'm continuing today. Uh, and let's see which question we can do today. So this question insert interval. I hope I have this. Yeah, DIY is there. I'll do it later. Maximum severity proper deep approach. Figure out how. This one we have done already, and we use trees and a text right. Uh, so how we are going to get multiple calls and all, we have done that here. DSA approach we have not done. I believe so. We can leave it for now. Not leave it. I'll do it. Just give me some time. I got an interview set up for myself in Walmart, and that is scheduled for third week of January. So I got some work to do. So I'll try to breeze through Walmart problems as well as these questions, right? So I've just started doing the medium question. I took a break, so I feel bad about it. Seriously. So I'll start with the zero one matrix. Let's see how much can I do today. So zero one matrix is like given. Okay, what was the? It is a graph problem and array dp bfs and matrix. So dp is zero. So given n by n binary matrix, return distance of nearest zero for each cell. Given distance between two adjacent cells is 1. Return the distance of the nearest 0 for each cell means okay, get it. Just trying to say. In binary matrix, return the distance of the nearest 0 for each cell. Any discussion around it? Let's take this input as below. We want to find the nearest 0 for cell 3 and 4. Okay. My what is the yapping, bro? Okay, guys, some use DFS this problem. 1 2 3 4 5 6, and again 1 2 3 4 5. Okay, got it. Means for every cell nearest zero distance we need to calculate, right? So zeros will not touch, and any cell, mm, wait, what is the question exactly? We need to return the matrix for, that means for the each cell we need to give the answer. So given we probably not going to touch zeros, and just measuring the distance like this one. For this one, all the zeros are at distance 1, so that is fine, and we have returned the answer. Now for this one, the nearest zero is at distance 1 only, I believe. Yeah, and for this one also that is correct. For this one, the nearest zero is going to be at 2 distance. That is answer of this previous. I guess that is what the TP means here. Let's see what he's yapping about. Then we'll see. Okay, in one pass. So given the cell ij, all the cells on tops and left are already pre-computed. Yeah, right. Now through this we will be able to reach we will be able to reach from this given one, that is at 3 4, all zeros, top left, top left, top left. Now after this we perform pass 2 from the bottom right. Yellow represent first pass, blue represent second pass, result followed by first pass. Sure. So here we can see probably has ignored 1 0 right here. Whatever. Performing top left will I mean, we are not doing diagonals, right? Why is saying top left then? Okay, performing pass the bottom right and all we find in the no. Now why we think this solution might be wrong in this example? We know the solution either top left or top left, nor bottom right and bottom right. Yeah, it is in top right, and okay, it is in bottom left as well. DP will take yellow path if you start from here. You're probably starting the traversal of the array from this point, right? But if you start the traversal of array from this point, it depends where you're starting your traversal, I believe, right? First pass alone gives this one, second pass alone gives this one. But in our solution, we did one pass followed by second pass. Alright. Now, what I think we can like given his uh, I guess no need for iPad. Given his image, I can try to think about my solution. Suppose I started from here, right? Then given a 0, I can start taking given a 0, I can start from 1, whatever the sum is. So I'll make it 1 1 1. Then I'll start from here. I'll make it 2. Suppose I'm at here at this cell, then I'll make it 2 and 2. That is correct. Then suppose I'm at this cell, right? At this cell, then I'll be making 2 plus 1, obviously, as I have not encountered any 0 here or there, anywhere, right? So I'll make 2 plus 1. If I encounter 0, I'll change it to 1. I believe like that how I'll work, and I'll make it 0. I mean 1 if it was 0. Okay. So but since it is not, so I mean either you do okay. So I'll make it 3, and suppose I started from here. So basically you'll have to follow a path. So at first pass, all of this is going to be 1 2 3 4 5 6 7. That is correct. Then next from this path into linearly, right? I hope to do it top and bottom. Better to do it linearly, probably. Let's see. Then this is already 1 1 2 3 4 5 6. Then we got 0, right? Then we'll make it 1. Hope so. We'll make it 1 because that is the correct answer, right? No? That is the correct answer. That's, so I guess our answer needs to be space over like it's top and bottom or right or anything like that. So since it needs an updated array each time, that is my problem in this case. So this guy is thinking about the path. I'm thinking about the array I have to return. Two passes I didn't get, like if it is something we need to think about. I think I got the solution, but you're saying two passes, right? So let me code out my solution. Okay, so we'll return math, obviously. Now we're going to create a new one, I believe, and probably we'll make or will not make. obviously going to push the coordinates, so that will be a pair of int and let's say q dot push 0, 0 start from top right, correct, and mm, alright, so while u dot empty I'm thinking about just updating the current index. So I'm thinking like if the current index is there, suppose I'm at this place, right? Suppose I've just visited this place and I've not seen any other place yet. Okay, so I don't know, like why will I ignore once we check the values? Okay, it will either be 0 or 1, it is saying. Fine. So basically, I guess I need to take out my iPad as my brain is not functioning very well these days. That is also the reason why I was not doing the questions properly. Okay. this one. Suppose we have this matrix, and this is the worst feature of OneNote. Like, ask for money, man, if you want. Don't be crappy. Remove this in that case. We'll just use the existing blocks as got my point. So yeah, suppose we have 0 here, 0 0 0 0, then 1 here, then 0, then 1, and then 1, then 1 1 1 0. Okay, then again 1 0 0 and 1. So I'll start from here. I'll see it is 0. Yeah, then I'll go to the I'll skip it because we are not going to upgrade the 0th. Let me check out one thing. Wait. Sorry. Let me check out this. So we have to give an example quickly. So we have the answer. We are not going to update the 0, right? So they have not updated the 0 in the output. So 0th row will not be touched. Alright. Yeah, so we have this. I'll start from here. I'll see and skip. Then I'll just post this one. So I have this queue. So 0 comma 0 will be pushed. Then next 0 comma 1 and 1 comma 0 will be pushed. This will be popped. Then you will go to 0 comma 1. This will push 2 comma 0 and 2 comma 0. Better I say 1 comma 2. Sorry, 0 comma 2 and 2 comma 0. Okay. Then this will also be popped. Will not do any operation as it is a 0. Other than that, we'll just make the neighbors 1 if they are not 0. Okay, we'll make the neighbors 1 if they are not 0. That is what we are going to do. So at 1 comma 0, we are at this place now. So let's see first what it will push inside the queue. So at 1 comma 0 it will push first 1 comma 1, right? 1 comma 1 it will push, and it will push 2 comma 0, 2 comma 0, 3 comma 0, and what it will update. So since it is 0, it will not update it, but this one it will update. It will say, see, I'm 1 away from the zeros, you need to be 2. So this will be updated to 2, and then it will be popped. So it will go to 0 2, and 0 2 is nothing but 0th row, this one. So this will push 0 3, and this will push wait, 0 3, and then 0 3 is pushed, and it will push 1 comma 2. So 1 comma 2 is pushed. So we have that in queue. Now what can it do? Nothing. It will go out. Now we are at 2 comma 0, and I guess I have done some mistake. So this pushed these two, then this got out. I had to push these two. So when I'm 0 comma 1, right? 0 comma 1 is this one. This will push 2 comma 0, that is 2 comma 1 actually. 1 comma 1 I mean. So this will be 1 comma 1, that is already pushed, and it will push 1 comma 1, I'm saying, and it will push 0 comma 2. So 0 comma 2 is already there, 1 comma 1 is already there. I think some mistakes has happened while explaining. I'm sorry. Let's have a Q. So we are at, let me write it down in small letter, so I will not make any mistake. 0 comma 0, 1, 0 comma 2, 0 comma 3, 2 comma 2, 3, 0, 3 comma 1, 3 comma 2, 3 comma 3. This feels like a K map, but numbering is off, yeah, for the K map obviously. So we'll push 0 comma 0 first. So 0 comma 0 is pushed. Now after popping 0 comma 0, we can push 0 comma 1, and we can push 1 comma 0. So we have popped, so 0 comma 1 is pushed and 1 comma 0 is pushed. So in symmetry they are being pushed, right? Kind of in symmetry. So not totally in symmetry, but yeah, or at least first element. I'm sorry, I'm talking too much. So after popping this 0 comma 1, as it is 0 and there's nothing, so it will push 0 comma 2 and it will push 1 comma 1. So after pushing 1 comma 0, popping I mean, we can push 1 comma 1, that is already there, so we are not pushing it, yeah, and so therefore I will need a visited array. Visited array required. I forgot about it. Okay. So 1 comma 1 is not pushed, and 3 comma 0 can be pushed, yeah. I mean 2 comma 0 can be pushed, so 2 comma 0 is pushed. Now 0 comma 2 is popped. Now do I want to do the update operation itself, or should I wait to go to the element and do the update operation? I believe I should do the update operation along with it, right? So I'll make it 2, just right there, as soon as push it. Now sorry, I made it 2. Now when we go to this 1 comma 1, I mean sorry, 0 comma 2, so 0 comma 2 can push 0 comma 3 and it will push 1 comma 2, right? So it cannot do anything until unless its neighbors are greater than 1, so it will make them 1. Okay, so these two are push and we have popped it. Now we are at 1 comma 1. Now all of the neighbors are 1 only, so that is fine. Yeah, I'll be updating before only, then that case. Got the situation where it can be messy. Not messy. Um, I guess both will be fine only. I'm sorry. So 1 comma 1 will push 1 comma 2 and 2 comma 1 in symmetry. Yeah, and 1 comma 1 is popped. Now with 2 comma 0, you can see both of its neighbor, and I can update them, right? We'll see later. So at 2 comma 0 we are here, and I need to mark the visited ones. So visited, right, and visited, 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 and visited. My brain is too weak right now. That is why I'm doing these dumb things. Visited, visited. Now let's do it. Popped it, added 1 comma 2, 2 comma 1. Now next one is 2 comma 0, and 2 comma 0 will be popped, and after popping it, I know 2 comma 1 is already there, so cannot push it, but 3 comma 0 we can push, and 3 comma 0 will be there. Now 3 comma 0 is also visited and updated to 3 and 3. Okay, now we are at 3 comma 0, right? So at 3 comma 0, 0 comma 3, 0 comma 3 is this one, yeah. So 0 comma 3 can only push 1 comma 3 as all others are visited. So we'll put 1 comma 3 here, 1 comma 3, and we'll pop 0 comma 3. Now at 1 comma 2 I can push 2 comma 2 and can update it, right? So I can update it with 2. So 2, pushed it, that's it. So 2 comma 2 is now pushed. 1 comma 2 is popped, obviously. Now we have 2 comma 1. Since 2 comma 1 has multiple 0 in its neighbor, right? So it will change itself to 1. Okay, so it will change itself to 1 back again. Now now let's do it further. So we were talking about 2 comma 1, right? It will push 3 comma 1 as well. So 3 comma 1 is pushed and marked as visited. What if something is 0 and we just don't push it? Will that work? Because in any case we are not going to update it, but yeah, we need the neighbor, right? So it's not like they're blockers. We do need the neighbors of them. So yeah, got it. So we are at 2 comma 1, and 2 comma 1's neighbors are already pushed, but and 2 comma 1 is updated. Now popped it. Now we are at 3 comma 0, and 3 comma 0 you can see one of our neighbors is 0, so we will update it to 1. and 3,0 is going to not push anything, so it is also popped. Now the turn is 1,3 and 1,3. You can see all of the things are already visited, leaving 2,3, so we will push 2,3, and now 2,3 is also visited. Now we will come here and make it, okay, I'm sorry. Yeah, now we have this 1,3 and 1,3 we have pushed 2,3, and as per the conditions we cannot do anything. 0 we will not update, and we see if we are greater than 1 we will just go back to 1, and we have 0, we are not going to do anything. And if our neighbor is not visited, we will increment it. If it is visited, we will not touch it, like that. So now we will go to 1,3 and we'll pop it, and now we'll go to 2,2, and 3,2 is not yet pushed, so we'll push 3,2, and we'll see its neighbor is literally 0, so we'll make it 1 back again, and 2,2 is done, so we'll just pop it. Now next one is 3,1, and 3,1 neighbors are absolutely fine, and we can continue, and we will go to 3,1 is done for. We'll go to 2,3, and 2,3 neighbor is 1, that is absolutely fine, and we'll just push 3,3. So 3,3 is pushed, and it is also marked as visited. Now at 2,3 we will come and see its neighbors are fine. And 3,2 this is also fine. At 3,3 this is also fine. I believe this solution I can apply. So we will need a visited array, obviously. Let's see how can I apply this. So I'll try to visit top, left, bottom, and right. So I'll do a direction array at int direction equals, so do 4 directions. So we'll try to go to the 0, 1, then we'll try to go to the this means right, we can try to go to bottom right. So I think do we require, I guess yeah, we should. I'll optimize it later. For now I'll do all the 4s. So for going down it is 1, 0, going up is -1, 0, and going left it will be 0, -1, and yeah. So we pushed it, there will be a condition, and we can do mnm int m equals mat dot size. Let's say this is number of rows, correct? So n will be column, so int n equals mat of 0 dot size, and push this one, that is fine. And what else? So we have x and y. So I'll say coordinates and int x equals chord dot first and int y equals chord dot second. Now we'll apply our logic here. So we'll try to iterate in the directions. So dir, I mean auto, d from dir, and we'll again have int 4, not 4, I guess d is a vector itself, 0, 1, right? So yeah, we can say int new x barabar x plus d of 0, int new y equals y plus d of 1. I believe this should be fine. Now we can check for the condition. If we'll just go for the valid ones, then we'll see if it is 0 or 1, then we'll apply our case, right? So if the coordinates are valid, first we will see. So if n is smaller than nx, it should be smaller than nx, and x will be basically I will try to say mx, sorry, and y is going to count the columns, right? And x is going to count the rows. Yeah, this is fine. And we will say, and y should be, I mean m should be less than ny, and x should be greater than, and x should be greater than equals to 0, and ny should be greater than equal to 0. Now visited array is required one, so I'll make that. I'll make that here. Okay, visited, just say v, this is fine. So visited is going to be there, and we'll just do m comma vector of n, no, I mean bool n comma false. Now I can put it below those variables, right? Hopefully the declaration is correct. So and then not visited, that is nx and ny. So I'll make that as false. Okay, means that it's true. So wait, what I'm trying to say is this one. Just after pushing whatever, I'll do visited of 0 equals true, and yeah, we'll now see, we'll anyhow going to make it visited as true. So visited of nx and ny equals true, and we'll start from here and we'll say if mat, okay, if mat of nx and ny means any positive value if it is there, we will do any positive value. Okay, so if any positive value is there, my god, this will be a little complex. So I'm trying to check in all the directions actually, not the nx and ny. I'm just I will just push the nx and ny, right? That will be fine. But for the x and y, we need to update, I believe. So, getting the point. I'm getting the point. Actually, getting the point. So, regardless of its value, we just push it, right? So q dot push nx comma ny. This is fine. Now how I'm going to update them is using x and y. So like I need to update the x and y coordinate thing as well as soon as I'm popping it, or I need to as soon as I'm pushing it, I need to check for this. So better to do it in this loop itself, I believe. That would be nice. So before pushing it or after pushing doesn't matter, we are doing in the matrix itself. So I'll just check if mat of x and y, right? If mat of x and y means if it is 0, and if mat of x nx and ny is not I mean if it is 0, then if they are as well as not 0, we'll just make them 1. So we'll do mat of nx and ny equals 1, and I'm making it unnecessary complex, I believe, else so current value of x and y should be updated to nx and ny, like yeah, else mat of nx and ny should be plus equals to mat of x and y. Let's see. Oh fuck, I submitted it. Let me use this test case and let me run it. Okay. So why this is not updated? This should have updated that, right? Maybe because of this visited condition, most probably. Let's put it outside. Okay, wow. All right. If they are 0, then in that case, if they are 0 as well, test case, this one. Okay. If given element was 0, right? And therefore I was thinking this should be outside. If we put it outside, let's see. Okay, conditions are not there, that is why. Okay, Cupid, may you down a melody of So this time it expected 0, but it is giving us 1. I can write on it, but do I want to? We'll see. Let me just think about it for a bit. So we are checking at the current place, right? So 0 should not be touched. That is the case. So I'm saying if it is 0, if it is a 0, right? If it is a 0, this means this is not a 0. Okay, so if it is not a 0, then you go here, okay, and check if the new ones, whatever they have given, like if it is not a 0, given area is not a 0, and the new ones, if they are not 0 as well, if they are not 0 as well, then touch them. If suppose I'm at this place, okay, let me get that yapper. Okay, here, it's fine. If I'm at this place, so I'm here, 0, it will say 0, that is false. False will become true, and we'll come here, we'll see this is also false, and this will become true. So we'll come and make it as 1. No. I mean, sorry, at this point this will not go inside this. At this point only this will go inside it, and after going inside, suppose it says the right one, so better to use it look like it will only go inside when it's 0, like 0 will be false and all other values will be true. Yeah, I guess so. 0 will be by default false, then why need this? Yeah, correct, no? So 0 will be by default false, and we are not touching that. Now else, if it is true, means when we are here, okay, we'll see and we'll say see brother, we are an x, right, and y, right? So just add a 1 into me, right? So it will definitely go at this place, no? It will go there, and we'll say, can I add you to myself? If I am here, it will go there, no? What will it take to go there? 1, 0, obviously. So second iteration. I'll just print it. If x equals 1 and y equals 1, see out matrix of this. Oh wow. No sucks GPT. I don't have this much time. Okay, so we have distance array. Oh, directions for traversal. I kind of got the solution. Maybe this is this distance. So and distance is -1. It is saying means that is unvisited kind of. Kind of like if it is -1, it is unvisited. That's it. So you're doing q dot push and whatever that boy is, will have 1 plus distance from the new one, and yeah, you will just update it. This logic checks out. Okay. Distance of nx and y equals distance of xy plus 1. And yeah. You can simply say if they are unvisited means that they are not touched. So it has set it as int max, right? So okay, let's stop this and I'll resume with some other bits.